ठीक है, थैंक यू। Hello, hi everyone. So I think we are live now. So can someone just confirm if I'm properly audible? Okay, thank you. So hi everyone, my name is Karan Masru, and today we are going to look at some of the previous year questions of data structures and algorithms which were asked in GATE. And let's just wait for 20 more seconds for more people to join, and then we'll continue. Okay. Okay, everybody please like the session. Today we will be solving some of the previous year questions. You might have also watched the previous revision of mine. The last one was computer organization architecture. Which subject will be of high weightage this time? See, every subject has a particular weightage, and out of that a plus minus 1 or 2% happens. Okay, if you look at the marks distribution online, then you will get the weightage of every subject, and in that you can say plus minus 1 or 2% or maximum 3% variation could be there in one subject. Okay, otherwise it doesn't change much. Okay, so let's begin. So let's begin with the first question. This was asked in GATE 2023. It says consider two functions of time. F of t is 0.01 t square and g of t is 4t. I hope this is visible, right? So it says that f of t is 0.01 t square and g of t is 4t, where t is from 0 to infinity. Now consider the following two statements. So two statements are given, and then it is asked which of the following is true. Only first is correct, or only second is correct, or both are correct, or both are incorrect. Okay, so what is the first statement? For some t greater than 0, g of t is greater than f of t. Dekho what it is said. For some t greater than 0, g of t is greater than f of t. Means what? If we get even one value of t which is greater than 0, which satisfies this condition, then the first case is true, right? So if I put t equals to 1, I can clearly see g of t is greater than f of t. If I say t equals to 1, g of t will be equal to 4, f of t will be equal to 0.01. So g of t is greater than f of t for t equals to 1. So my first statement is correct. Second statement, there exists a capital T such that f of t is greater than g of t for all t greater than t. What does second statement say? That there exists a particular value of t such that for all the values of t greater than this t, after this t, for all the values of t, f of t is greater than g of t. For all values, remember here it is not there exists, this is for all t greater than capital T, f of t is greater than g of t. Okay, so this is also true. Why? Because one, you can have a look at the equation and understand that this equation is increasing, this function is increasing with respect to t square, and this is increasing with respect to t. Now because here the coefficient has large value as compared to this, g of t might have bigger value than f of t for some values of t, but ultimately as the value of t increases, t square will dominate the small t, and hence f of t will be greater than g of t. Okay. So you can also look at in terms of time complexity. This is big O of t square, this is big O of t. So ultimately this will be bigger. But we can, if I want to find the value of capital T, I can also do that. So I can say for all t greater than t, f of t is greater than g of t. So I can say 0.01 t square is greater than 4t. This is true for all t. Now find the value of t. So 1 t equals to 0 will get cancelled out. So 0.01 t is greater than 4. So t is greater than 400. So let's say it is in seconds. So my capital T became what? 400. After the value of this, f of t is greater than g of t for all values of t. Hence both of them are correct. So option C is the correct answer. Is this clear? No, 0.01 will not be always less than 4x, because it also has t square, na? So ultimately it will become bigger. Good morning, Satish. Okay, is this clear? Shall we move on to the next question? Also guys, please reply quickly. If you have any doubt, then let me know quickly. If you do not have, then write clear so that we can move on to new questions quickly. Okay. Is the first question clear? Can someone reply? Okay, let's move on to the next question. Okay, what does this question say? It says that which one of the following sequences, when stored in an array at locations this, form a max heap. Okay, now you see here these elements are stored in array from 1 to 10 locations. Okay, and they are saying that which of the following will form a max heap. Now max heap is in terms of binary tree. So they are treating this array in terms of binary tree. Okay. So if I have an array whose indexes go from 1 to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. How can I visualize this array as a binary tree? The first node will be the root node whose index is 1. Its left child will be the second node and right child will be the third node. Okay. Now the left child of second will be 4 and the right child will be 5. Okay. So in general, for a particular node I, the left child will have 2i index and right child will have 2i plus 1 index. For example, this node is of second index, then left child is 2i, that is fourth index element, and right child is 2i plus 1, fifth index element. Okay. Now please don't get confused. Sometimes you might also see for a particular node I, the left child is 2i plus 1 and right child is 2i plus 2. Okay. So when will this apply and when will this apply? If your root node is starting from index 1, this will be considered. If the root node is starting from index 0, this will be considered. Okay. Here it is said that indexes are from 1 to 10. So in this way the tree will be formed. And so the first element will be the root node, then the left child and right child will be second index, third index, then fourth index, fifth index. Here the left child will be sixth index, right child will be seventh index. Here the left child will be eighth index, right child will be 9th index, and here the left child would be 10th index. Okay. Now they have said which of the following will form a max heap. Now what is a max heap? Max heap is a binary tree in which the node has larger value than all its children, and this is true for all the nodes. So the largest value will be at the top, let's say 50, this is 45, and this is, let's say, 40. Now here the nodes will have value even less than 45, okay, because their children will have value less than this, 50's children will have value less than 50, and so on. So let's say I have 39, I have 37, here I will have 38, here I have 32, here I cannot put 42 because 39 is less than 42. In a max heap, the node has larger value than its children. So here let's say I have value 30, here let's say I have value 28, here let's say I have value 19, here let's say I have value 20, here I have value 21, here I have 23, and so on. Okay. So it is asked which of the following will form a max heap. So let us put the values in the binary tree and observe. So let us check the first one. Okay. First is 23, 17, 10, 6. So 23, 17, 10, 6. 13, 14, 1. 13, 14, 1. 5, 7, 12. Is it forming a max heap? No. Here you see 7 is greater than 6, even then it is the child of 6. So this is not forming a max heap. Okay, even 14 is greater than 10. So your A option is not correct. Now let's try with the B option. Okay, let me just rub this out. Okay, let us put the B option. 23, 17, 14, 7. 23, 17, 14, 7, 13, 10, 1, 5, 6, and 12. Now is this forming a max heap? You see 23 is greater than 17 and 14. Okay. 14 is greater than 10 and 1. Okay. 17 is greater than 7 and 13. Okay. 7 is greater than 5 and 6. Okay. 13 is greater than 12. Okay. So this is forming a max heap. Now you can also check out for options C and D. They will not form. Okay. If we just quickly check them, then let's check for option C. 23, 17, 14. 23, 17, 14. 6, 13, 10, 1, 5, 7, and 15. Now you see 15 is greater than 13. It cannot be 13's child. So this is not forming a max heap. And similarly for option D, let's check. 23, 14, 17, 1. 23, 14, 17, 1. 10, 13, 16. 10, 13, 16. 12, 7, 5. 12, 7, and 5. You see 12 is greater than 1. It cannot be 1's child. Okay, so this is also not forming a max heap. So your correct answer is B option. Okay. Yes, B is the answer. Clear? Shall we move to next question? Yes, the right node C. If the root node is at 0 index, then in this case, for a particular node at index I, the left child will be at 2i plus 1 and the right child will be at 2i plus 2. But if the root node is at index 1, then for a particular node I, the left child will be at 2i index and right child will be at 2i plus 1 index. Okay. Let's move to next question. What does this question say? It says that let SLL be a function that deletes a node in a singly linked list given a pointer to the node and a pointer to the head of the linked list. Okay, so SLL delete is nothing but deletion in singly linked list. Okay, and what we are given? We are given pointer to node which is to be deleted and pointer to head of the linked list. Okay, now similarly let DLL be another function that deletes a node in doubly linked list given a pointer to the node and a pointer to the head of the linked list. So there is another function DLL delete which is deletion in doubly linked list, and here also we are given pointer to the node which is to be deleted and pointer to the head of the linked list. Okay, let n denote the number of nodes in each of the linked list. Total there are n nodes in each linked list. Which one of the following choices is true about the worst case time complexity of deletion in singly linked list and deletion in doubly linked list? And 4 options are given. Okay, so how can we solve this question? You see here, suppose you are given a singly linked list. Okay, and this is your head pointer. Let's say you want to delete this node, so you have a pointer to this node also. Let's say T, this is also given in the question. Now you want to delete this node. If you want to delete this node, what you need to do is you need to take the next pointer of this node, which is this, and connect it here. Are you getting my point? You take this pointer, next pointer of the previous node, and connect it with this node, so this node vanishes and you get the new linked list, right? So in order to do that, you must have access to this node, because when you have access to this node, let's say this is node, the pointer to this node is P. Okay, so and the pointer to this node is T. So can I say P next is equals to T next? What will this do? Look here, P next is this node, T next is P next is this pointer, T next is this pointer, because the pointer pointing to this node is T. So P next is equals to T next. Okay, this is T next. So when you do this, this node vanishes from the between, right? So you need to do that. In order to do that, you need access to this node, right? But you do not have that. So what you need to do is you need to start traversing from the start of the linked list and stop when P next is equals to T, because this is the node you want to delete. So when P next is equals to T, it means this is the pointer to the previous node. Once you reach here, after that you need to say P next is equal to T next. Okay, and you can also free the memory allocated to this node. So you need to reach to the previous node, and how will you reach? Starting from the head node, you keep traversing until this condition is not true, right? So basically you say P is equals to head node, and while P next is not equal to T, P is equals to P next. Okay, and after coming out of the while loop, you say P next is equals to T next. Okay, so because of this while loop, worst case will be what? You need to traverse the linked list. Traversing a linked list takes how much time? Big O of n time. So for singly linked list, the deletion time is big O of n. Okay, now let's talk about doubly linked list. Okay, So let's say this is the doubly linked list you are given and you want to delete this node. So a pointer to this node is also given. Okay. Now you are given T and head. Now how will you delete a node in a doubly linked list? So what you basically do is you go to the previous node. Okay. Now we do not need to understand the complete implementation because we are not going to write the code here. I will tell you the approach, right? So what you do is for the previous node, I'll write it in different color. This is the node to be deleted. So I'll go to the previous node and I will make its next pointer point to this node, and I will go to this next node and I will do its previous pointer pointing to this node. Are you getting my point? So this pointer which is pointing here right now will point to this node, and here the previous pointer which is pointing to this node here will now point to this node. Okay. Now in order to do that, I need pointers to this node and this node, right? Like how I needed the pointer to the previous node here. Now do I need to traverse from the head of the linked list to get this pointer? No. Why? Because let's say this is T1 and let's say this is T2. I can directly say T1 equals to T previous because this is doubly linked list, and T2 is equals to T next. In one step only I will get it, right? And then after doing some manipulation, I will make the next pointer of this T1 next equals to T2 and T2 previous equals to T1. So this node will disappear and I can free the memory allocated to it. So how much time is taken? I was given pointer to this node which needs to be deleted. In one step only I got the pointer to the previous node, and in one step only I got the pointer to the next node. Now I just need to assign the next pointer to this and this previous pointer to this. Work is done. So constant amount of work is done. 4 or 5 steps are only needed. So it will be done in big of one time. In both the cases I need the access to the previous node, but here since there is no previous pointer, I needed to start from the head and traverse till the previous pointer. Here I can just simply say previous and next. Okay. So your correct answer will be what? Singly linked list is big O of n and doubly linked list deletion is big O of 1. Is this clear? Yeah. For a singly linked list we have big O of n. Okay, clear guys? Let's move to next question. I have a question, why don't we move from big O of n to move from start to the point that we want to delete in doubly linked list? Because in doubly linked list you have pointer to the previous node as well as to the next node. So if you are given pointer to the node which is to be deleted, you can get the pointer to the previous node by just saying T1 equals to T previous. If you can do it in one step, why will you traverse the complete linked list? Okay. So here what it is said, an algorithm has to store several keys generated by an adversary in a hash table. So we need to store some keys in the hash table. The adversary is malicious who tries to maximize the number of collisions. Okay. Let k be the number of keys, m be the number of slots table, and k is greater than m. So m be the number of slots in the hash table, k be the number of keys, and number of keys is much greater than m, and the person is also malicious. Okay. So he will try to maximize the collision. Okay. Which one of the following is best hashing strategy to counterattack the adversary? Now you see here, one of the options is universal hashing method. Now whenever it is asked which of the following is the best hashing method and universal hashing is there in the option, you directly take that answer. Why? Because that's the best hashing method which counteracts everything, and it's a complex method which is not it's just said that this is the best method. It is not taught in detail how it is implemented. So your answer would be C here. Other than that, if you see, one is the division method that uses hash function h of k equal to k mod m. Okay, now let's say your m is, let's say, anything. Let's say you take 29. Okay, so if I take a key with value 30, then h of k would be 1 because 30 mod 29 is 1. Then you take key equals to 59, then also h of k would be 1 because 29 into 2 is 58, and this will also give 1. Similarly, there can be a lot of k values which will give the same hash value, so there will be collision. So division method is gone. Multiplication method, that is, use the hash function h of k equal to this, where a is carefully chosen. Now you see here, whatever a carefully you choose here, I can select some values like how I did in division, such that collision obviously happens. Okay, because whatever a value you select, that becomes a constant. Your m is constant. Now k minus this value, that will only remain, right? So that will also not work, right? Another is the third one, the last one is, if k is a prime number, use division method, otherwise use multiplication method. Again, I mean, k is prime or not, I can always get collision, right? I can get different values, and in multiplication method also, right? And the universal method is also given. So obviously this is the best one, and here, as I shown you, there might be collisions. Clear? Let's move to next question. Okay, what does this question say? Let A be a priority queue for maintaining a set of elements. Okay, so A is a priority queue which is used for maintaining a set of elements. Suppose A is implemented using a max heap data structure. So this priority queue is implemented using max heap. The operation extract max A extracts and deletes the maximum element from A. The operation extract max A, it gives you the maximum element value and also deletes it. Okay, the operation insert A key inserts a new element key in A. Insert A key, this will insert a new element key in the max priority queue A, or the max heap. The properties of max heap are preserved at the end of each operation. So after doing extract max or after doing insert, the properties of the max heap must be maintained. Okay, when A contains n elements, which of the following statement is true about the worst case running time of these two operations? Suppose the max priority queue contains n elements, then what will be the time complexity for this as well as for this? That is asked in the question. Okay, so how can we do this? First of all, how does max heap, so what is a max heap? As we discussed, it is a complete binary tree, or you can say binary tree, in which the node value has the bigger value than its children value, and this is true for all the nodes. Okay, so let's say I have a max heap. Let's say I have 50, I have 48, I have 45, I have 40, then I have 42, I have 41, 43, and I have 38, I have 36, 32, and let's say 20. Okay, now let's say I want to extract max A. So I want to get the max value of the priority queue, and then after getting that value, it is also to be deleted. and after deleting it also the properties of the max heap must be maintained. Okay, so how do we do this operation? See, the max value will always be at the root node in max heap. So first of all, I'll return this value 15. Now I also need to delete it, but after deleting it my max heap will get disturbed. I also need to maintain it. So how do we do that? We replace 50 with the last value. Okay, so we replace 50 with the last value. Now this is implemented using an array. Okay, so this is 0 index, this is first index, this is second index, this is third index, fourth index, fifth index, sixth index, 7, 8, 9 and 10. So at present my number of elements are how much? 11. Once I replace this with this, I will say n minus minus, that is my array became of 10 size, so this node will be deleted. Okay, now but the property of max heap needs to be maintained. Here it is not maintained. So what I will do is I will replace 20 with the maximum child out of the two childs if they are greater than 20 until the property of max heap is not preserved. So here 20 is less than 48 and 45, so it is not preserving the max heap property. So I will exchange 20 with 48 because 48 is bigger. So I will say 48 and I will say 20. Now 20 is less than 40 and 42, so now I will replace it with 42. Okay, so this is 42, this is 20. Now 20 is less than 32, so now I'll replace it with 32. So now the property of max heap is satisfied again. So what I need to do, if I want the max element, I'll take the maximum value of the, I'll take the root node value, then replace it with the last node value, and then keep bringing that value bottom until the max heap property is not satisfied, right? So how much time this will take? This will take the time equal to the height of the tree, right? So it will take log n base 2 amount of time, this extract max. Okay, now let's talk about insert a key. So whenever you want to insert a new value, what you do is you insert it as the last index and then you keep exchanging it with its parent value until the max heap property is not satisfied. For example, I want to insert the value 45. So what I'll do, I'll insert the value 45 here at the last node and keep exchanging it with its parent until the max heap property is not satisfied. Now 45 is greater than 32, so 45 and 32 will be exchanged. Okay, so 32 will come here and 45 will come here. Now 42 is greater than 45 is greater than 42, so again these two will be exchanged. So 45 will come here and 42 will come here. Now 45 is less than 48, so nothing will happen and we got the max heap. Okay, so how much would be the time complexity? See, we are inserting a node at the last node and then keep moving it above, okay, until we reach to a level where max heap property is satisfied. So in the worst case, I need to go to the root node. Okay, so that will again take how much time? Big O of log n base 2, that is the height of the binary tree, okay, or the max heap. So your answer for this question would be both will run in log n time. Yes, we have log n for both the cases. Okay, done guys. Shall we move to the next question? Okay, let's look at this question. See, all these questions were asked in 2023 only. Okay, a lot of questions from DSA, and this is also scoring, like the questions are not that tough. If we see, if your concepts are clear, you can easily attempt them. Consider the functions function 1 and function 2 expressed in pseudocode as follows. So we are given pseudocode of two functions. Let f1n and f2n denote the number of times the statement x is equals to x plus 1 is executed in function 1 and function 2. Okay, so f1 of n is the number of times the statement f equals to, x equals to x plus 1 is executed in function 1 and f2 of n is the number of times the function, this statement, this is executed in function 2. Okay. So then the relation is given that f1 belongs to big theta of f2n, f1n belongs to small o of f2n, f1 of n belongs to small omega of f2n, and f1 of n belongs to big O of n. Okay. So first of all, we need to see how many times this statement is executed in f1n and f2n with respect to n, that is the input. So what will be f1 of n? Let us calculate. Here, while n is greater than 1, for I equals to 1 to n, do x equals to x plus 1 and then divide the value of n by 2. So what is happening is, we have an outer while loop. Let's say the value of n is 32. Okay. So here the inner loop will run for I equals to 1 to n, the inner loop will run 32 times. Now the n value will become 16 because n equals to n by 2. Now the inner loop will run 16 times. Then n value will become 8, inner loop will run n times, then n value will become 4, inner loop will run 4 times, n value will become 2, inner loop will run 2 times, n value will become 1, inner loop will run 1 time. Okay, this will not be executed because we only run while n is greater than 1. So when n equals to 1 happens, we come out of the outer while loop. Okay. So how many statements are executed? I can say n plus n by 2 plus n by 4 plus n by 8 and so on, right? So how much time does this will take? If I take n common, I get 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 and so on, right? And the last would be 2 की power n, last would be something like 2 की power m, because here it is n, then n by 2, then n by 4, then n by 8. Ultimately it will become n by n, then only it will be 1, right? Ultimately it will be n by n, out of which n I have taken in common. Okay. So let us write 2 की power m, because this is increasing with respect to what? This only, right? So I can do it in this way, or what I can do is I can assume this to be here the ratio is what? This is geometric progression and the ratio is 1 by 2, right? So what is the sum of the geometric progression with ratio less than 1? It is a upon 1 minus r, where a is the first term. First term is what? 1 upon 1 minus r, r is 1 by 2. So the sum of this will be what? 2. 1 upon 1 minus 2 is 1 upon 1 by 2, which becomes 2. So overall the f1 value is what? N into 2, that is 2 into n. So f1 is 2n. Okay, is this clear? Now let's see f2 value. What is f2? It is simply running from 1 to 100n. So f2 is how many times this statement will be executed? 100n times. Here it is executed 2n times, here it is executed 100n times. First statement is f1 of n belongs to theta of f2n. This statement is true. Why? Because this is increasing with respect to n. 100 is constant. In asymptotic notation we do not consider constants. This is also increasing with respect to n, right? 2 is constant, so I say f1 belongs to big theta of f2n. f1 of n belongs to small o of f2n. This is not true. When do we say small o? When f2 of n is giving an upper bound to f1 of n, but that is not tight upper bound. For example, f1 of n is n and f2 of n is n square or n cube or n की power 4. Then I can say f2 of n gives upper bound to f1 of n using small o notation. So this is also false. This is false. f1 of n belongs to small omega of f2n. This is lower bound. This is also not true. Both of them are equal. Here if it was big omega or here if it was big O, then it would have been correct. But since they are small o and small omega, this is not correct. And f1 of n belongs to big O of n. That is true. 2n belongs to big O of n. This is increasing with respect to big O of n. So A and D are the correct options. Okay, shall we move to the next question? क्लियर है ये सबको? Okay, this is a very simple question, again asked in GATE 2023. Okay, thank you for giving the heart. You are liking the session. Okay, let's look at this question. What does this question say? Consider a sequence A of elements A0 equals to 1, A1 equals to 5. So A0 is 1, A1 is 5, A2 is 7, A3 is 8, and A4 is 9, and A5 is 2. Okay. The following operations are performed on stack S and QQ, both of which are initially empty. So we perform some operations on stack and Q which are initially empty. Let me take this as my stack and this as my Q. Okay. Push the elements of A from A0 to A5 in that order in stack. So push the elements from A0 to A5 in that order. So first push A0, then A1, then A2, and so on up to A5. So A0 will come here, then A1 will come. Okay. After that A2 will come, after that A3 will come, okay, then A4 will come, and then A5 will come, right? Now NQ the elements of A from A0 to A5 in that order in Q. So now push the elements in Q, 1, 5, 7, 8, 9, 2. Okay. Pop an element from S. Pop means remove the top element. Remove the top element. DQ an element from Q. Let's remove the first element. Here it is last in first out. There it is first in first out. Okay. Pop an element from S. Pop an element from S. DQ an element from Q. DQ an element from Q. Let us remove it. Okay. DQ an element from Q and push the same element into stack. So DQ the element from Q, so you remove 7 from here and push the same element in stack. Repeat operation 7 3 times. So you repeat the 7th operation 3 times. So DQ from here and push it here. So you push 8 here, then 9 here, and then 2 here. So this will become 8, 9, and 2, and you remove it from the Q. Pop an element from S, pop an element from S, pop 2 elements from S. The top element of the S after executing the above operation is, what is the top element? 8. So your answer is 8. Okay, very easy question. Let's move to next question. Again very easy, asked in 2022. Okay, what does this question say? A palindrome is a word that reads the same forwards and backwards. In a game of words, a player has the following 2 plates painted with letters. So first of all, the definition of palindrome is given. What is a palindrome? It is a word that reads the same from start to end and from end to start. So if you read from start to end, it is ABCBA, and if you read it from end to start, it is ABCBA. Okay. From the additional plates given in the option, which one of the following combination of additional plates will allow the player to construct 5 letters of palindrome? So you need to select some plates, either these 3 plates or these 3 plates or these 3 plates or these 3 plates, such that using the 5 plates you can form a palindrome. The player should use all 5 plates exactly once. All the 5 plates must be used, and the plates can be rotated in their plane. Okay, so they can be rotated. For example, this is ulta D, right? You can rotate it and make it the D. Okay, so looking at the options, what I can do? A D D D J, A D D D J. You can never form 5 string palindrome, 5 length palindrome using this. Another is, this is R A R. So you have A D R A R. You can form a palindrome with this. Take the D in the center, 1 R here, 1 R here, 1 A here, 1 A here. This is a palindrome. So this is your correct answer. Others two also you cannot form. Okay. Is this clear? This is an interesting question. Okay, clear. Shall we start with the next question? Palindrome string quiz. Okay. So what does this question say? Which of the following statement is true for all positive functions f of n? First of all, f of n is said positive. Okay. Now f of n square is equals to theta of f of n ka whole square, where f of n is a polynomial. Let's wait for this option. Okay. F of n square is a small o of f of n ka whole square. Let us wait for this also. F of n square is equals to big O of f of n square, where f of is in an exponential function. Let's execute this first. Why? Because here they have specified the function type. So f of n square is equals to big O of f of n ka whole square. So f of n ka whole square will give an upper bound to f of n square when f of n is an exponential function. Let us check it. Let us say my f of x is e ki power x. So my f of x square would be e ki power x square, and f of n ka whole square, f of x ka whole square would be equal to e ki power x ka whole square, which is nothing but e ki power x into e ki power x, which is nothing but e ki power 2x. So it is said that f of n square is equal to big O of f of n ka whole square. F of x square is equals to big O of f of n ka whole square. This is absolutely false, because let's say your x value is 4, then this is e ki power 8, this is e ki power 16. So this cannot give an upper bound to this because this value is larger. So your option C is false. Now if option C is false, option B is also false, because here it is small o notation, that also gives an upper bound. Here the function is not specified, so you can take any function. So let us take f of n as e ki power n only, because it will fail on that case. So we can eliminate this also, right? Now let's look at this. F of n square is equal to big omega of f of n ka whole square. What is big omega? It gives lower bound. Okay. Now please understand, if f of n square is equals to big O of f of n ka whole square, when I took f of n as exponential function, it couldn't give upper bound, right? So what is here? I want lower bound, here I want upper bound. If exponential function failed on upper bound, then the inverse of exponential function will fail on lower bound. What is the inverse of exponential function? Logarithmic function. So in this case, I will take f of n as log n. It will fail on this. Okay, log n will pass on this and exponential function will pass on this. Okay, but we are checking which statement will be true, and we know that exponential function failed to give an upper bound here, so logarithmic function will fail to give a lower bound here. Okay, your exponential function couldn't give upper bound. So if I take f of n as log n, then f of n square would be what? Log n ka square, which is equal to 2 log n, and f of n ka whole square is what? Log n ka whole square, it is log n into log n. So f of n ka whole square is bigger than f of n square, so it cannot give lower bound, it can give upper bound. So this statement is also false, and hence your option A is correct by elimination. You can also check it otherwise. See, f of n square is theta of f of n ka whole square. What is theta notation? It means lower bound as well as upper bound. Or can I say the highest polynomial term here and here would be same, right? So take any polynomial function. Let's say f of n is equals to a ki power k plus a n ki power k plus b n ki power k minus 1 plus and so on plus z. Okay, this is a1, b1 and so on. There might be many terms. When I do f of n square, the highest term would be what? N square. So this will become square. So this will be n ki power 2k, and other terms will be there. Here there will be a constant, but the highest term is what? N ki power 2k. And when I take f of n ka whole square, so if I multiply this with itself, what will be the highest term? N ki power k into n ki power k. Again the highest term would be n ki power 2k. So the highest term is remaining same only, whether you take f of n square or f of n ka whole square, right? For specific values of constant, one of them might be bigger, but since we do not consider constants in asymptotic notation, so and the highest term is same in both of them, so they both are exact, I can say, in asymptotic terms, so it gives a theta bound. Okay, so option A is correct. Okay, clear? So this type of questions, what you do is you check the options where function is specified first, because your function is not specified. How will you proceed? You will need to take different functions. It will waste a lot of time. So directly come here. Here it is said exponential function, it fails. If exponential function fails to give upper bound, this will also fail on exponential. This is also false. If exponential function fails to give upper bound, logarithmic function will fail to give lower bound. This is also false. Option A is correct. Clear? Let's move to next question. What does it say? Consider the problem of reversing a linked list. To take an example given below, understand this. So we are reversing a single A linked list. Okay, so it is A, B, C, D, E. Now you have the head pointer pointing to the node having value E, then you get D, then C, then B, and then A. Which one of the following statement is true about the time complexity of algorithm that solves the problem in big O of one space? So we do not have to take any extra space, and we need to reverse the single A linked list. So what is the best algorithm? Best algorithm works in big O of n time, right? So let's say this is your linked list, single A linked list. Okay, and this is your head pointer. So how do we do? What we do is, so I am not writing the code, but just to make you understand, we take a next pointer here, we take a current pointer here, and we have another pointer previous which is initially null. Okay, now I say current next is equals to previous. So this is my current node, this is my current next. So what will happen is, my current next will start pointing to previous. Okay, so this will start pointing to previous. Previous is null, so this will start pointing here. After that, what I do is, I say previous is equals to current, so previous will go away from here and will start pointing here. Okay, this will become my previous. Then I say current equals to next. At present current is here, it becomes equal to next. So it becomes equal to next. Okay, so your current becomes here, and your next is equals to current next. So your next will come here. Now again you say current next is equals to previous. So what will happen? This is current next. Okay, so this will go away from here and it will start pointing to previous. Where is previous pointing? Previous is pointing to this node, so this will start pointing to this node. Okay, after the next step, what will happen? This will be removed and it will start pointing to this node. After the next step, what will happen? This will be removed and it will start pointing to this node. After that, your one pointer will come. When you come out of the loop, your current will become equal to null, and this will be your previous. Okay, and then after coming out of the loop, you can say head equals to previous. So your new head pointer will be this pointer, and your linked list is reverse. Okay, and this head is already gone. Okay, your head pointer is now there, so your linked list is reverse. This was null. Okay, so your linked list is reverse. So it takes how much time? It takes big O of n time. Basically you loop and then you move the pointers backwards. Okay, so the best algorithm from the problem takes theta of n time in worst case. The best algorithm takes theta of n log n. The best algorithm takes n square, and it is not possible to reverse a linked list in big O of one space. What is the correct option? A. Could you please introduce backtracking? It would be difficult to introduce backtracking here, like because we are looking at some PYQs. Okay. Again, a good question. What does this question say? I hope the last question is clear, everyone. What does this question say? Suppose a binary search tree with 1000 distinct elements is also a complete binary tree. Okay, the tree is stored using an array representation of binary heap trees. Okay, assume that the array indexes start with 0. What does this mean? For the ith node, the left child will be 2i plus 1 and the right child will be 2i plus 2, as we discussed before. The third largest element of the tree is stored at which index? That is the question. Okay, now you understand here there are a few terms which we need to understand. One is, it is said that it is a binary search tree. What is the meaning of binary search tree? Binary search tree means for a particular node, all the nodes in its right subtree will have value larger than that node, and all the nodes in its left subtree will have value less than that node. Okay, and this will be true for all the nodes. So let's say this is my node 50. Here I have 55. Here I have 52. Here I have 57. Here I have 56, here I have 60, here I have 40, here I have 48, here let's say I have 35, here I have 32, here I have let's say 38, here let's say I have 42, here let's say I have 49. So here for all the nodes, their right subtree, all the nodes have values greater than that node. For example, for 50, all these nodes have larger value. For 55, all these nodes have larger value. And for left subtree, all the nodes will have smaller values. So for 50, all this node has smaller values. For 40, all the left subtree nodes have smaller values, but right subtree nodes have larger values. Okay, so this is a binary search tree. Now they have said that it is also a complete binary tree. Now what is the meaning of complete binary tree? Complete binary tree means all the levels until the second last level of the binary tree are filled completely, and the last level nodes are as left as possible. So let's say if I have 20 nodes, so this is my first node, second node, third node, fourth node, fifth node, sixth node, seventh node, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. This is a complete binary tree. Why? Because until the second last level, all levels are full. Full means it is maximum possible filled. For example, if this node is not there, then this is not complete binary tree. Okay, so until the second last level, all the nodes are full, and for the last level, the nodes are as left as possible. So you cannot say it like this. This is not a complete binary tree. Okay, so this is a complete binary tree. and we are given a binary search tree implemented in the form of complete binary tree with 1000 distinct elements, and we are asked the index of the third largest element. Okay, now let's take an example for 20. Now binary search tree means the larger values will be on the right side and the smaller values will be on the left side. So if I have 20 elements, then the rightmost value will be the largest value. Yes or no? This will be the largest value. This will be the second largest value, because on the right hand side of it only this node is there, and this will be the third largest value. Yes or no? Because these three nodes are on the right side of this, which is on the right side of this. So ultimately this is the largest, this is the second largest, and this is the third largest. Okay, so what will be the node number of this? That I need to tell, index number. Now here it is said that it is implemented using array, which we saw before also, and index starts with 0. So this would be 0 index, this would be 1 index, this would be 2 index, this would be 3 index, this would be 4th index, this would be 5th index, this would be 6th index, 7, 8, 9, 10, 11, 12, 13 and 14. Okay, so the answer for third largest element would be at 13 index. Okay, now if we are given 1000 distinct elements, then what would my binary search tree look like? The level 1 will have 1 element, level 2 will have 2 elements, level 3 will have 4 elements because it is complete, level 5 will have 8 elements, level 6 will have 16 elements, then 32 elements, then 64 elements, then 128 elements, then 256 elements, and then 512 elements. Actually it will not be 512 because the sum of elements till here would be 511 and total elements are 1000. So in the last level the number of elements would be how much? 1000 minus 511, that is how much? 500 minus 11, that is 489. So this 489 means last level is not full, it is something like this. So there are 489 elements in the last level, and above them all the levels are full. So before this level, the last level was this, which had 256 elements. In that the last element was the largest and it was at 14 index, and the third largest element was at 13 index. So the largest element in this, see total there are 511 elements, but index starts with 0. So the largest element will be at 510th index, like how here the largest element was at 14 index and the third largest element was 1 index before it, 13. So the third largest element would be 1 index before this, that would be 509. So 509 would be your answer. Okay, clear? Shall we move on to the next question? Let's move to the next question. Could you please explain 510 elements? Okay. See, total there are 1000 elements. Okay. So the first level will have 1 element, the second will have 2 elements, the third will have 4 elements, like how here the first level has 1 element, then 2, then 4, then 8, then 16 and so on. So the first level has 1, then 2, then 4, then 8, then 16, then 32, then 64, then 128, then 256. Up till here the total number of elements are 511. If you sum up all these elements, it is 511. Now total there are 1000 elements. the capacity of the next level is 512 elements, but we require only 489 elements. Like here, the capacity of this level was 16, but I require only 5 elements, so others will be left empty. Similarly, here only 489 elements will be taken. Okay, so the last level will not be completely filled. Now for the second last level, the last element is the largest. Okay, sorry, for the second last level, the last element in that is 14th index is the largest. Now second last level ends here. How many total elements are there till here? From 1 to 4, if you sum up all these values, 1 plus 2 plus 4 plus 8 plus 16, 32, 64, 128 and 256, you get 511 elements. Like how you get 15 elements here. For example, 1 plus 2 is 3, 3 plus 4 is 7, 7 plus 8 is 15. Okay, total elements are 15 till second last level, but the index of the last element is 14. Elements are 15, but the last index is 14 because index starts with 0. Similarly, here the number of elements are 511, but the index will be 510 of the last element. Okay, and we want third largest. Now you see here, largest was at 14 index, third largest was at 13 index. Here the largest is at 510 index, so the third largest would be at 509 index. With here how one index was less, here also one index would be less, so the third largest element is at 509. Now is it clear? Is it clear now? Okay, great. Let's move to the next question. Okay, simple question. Consider a graph, simple undirected graph of 10 vertices. If the graph is disconnected, then the maximum number of edges it can have is. So it is a simple undirected graph, means the edges do not have a direction and it is simple. Simple graph means what? It will not have self loops like the edge towards itself, and it will not have parallel edges, like there will not be multiple edges between two nodes. Okay, it has total 10 vertices. If the graph is disconnected, what is the meaning of disconnected? Connected means what? There is a path between each and every pair of vertex. Disconnected means what? There is not a path between each and every pair of vertex. Okay, then the maximum number of edges it can have. Now I want to maximize the number of edges, so the number of connected components I want to keep it disconnected, but I want to minimize the number of connected components. Why? So that I can have more edges. For example, if I keep all the 10 components separately, then there will be no edge between any of them, but I want to maximize the number of edges. So what I will do is I will make two connected components. There will be some nodes here and some nodes here. Okay, and I will try to see that there are maximum edges possible here and maximum edges possible here. Why? Because I want maximum number of edges. Now there is no edge between a node here and here, so it is disconnected. But among this in this connected component, I will try and make sure there is an edge between each and every pair of vertices. Okay, so I need to divide 10 vertices into two parts, and then in individual part I will assign maximum edges, so the total number of edges are maximum. So how can I divide this 10 vertices into two parts? I can put 5 vertices in one and 5 vertices in another, or 6 in one, 4 in another, 7 in one, 3 in another, 8 in one, 2 in another, 9 in one and 1 in another. Okay, how many edges would be there here? You see here, if this component has 5 vertices and this component also has 5 vertices, I am not making any edge between a node here and node here, but inside this I can make an edge between each and every pair of vertices, so the total number of edges would be 5c2. So for this component ages would be 5c2, and for the second component also ages would be 5c2. So this is how much? 5c2 is how much? 10. 10 plus 10 is 20. Here it would be 6c2 plus 4c2. 6c2 is how much? 21. 21 and 4c2 is how much? 6. So this will be 27. So we are increasing. Here it was 20, here it was 27. So this will give max value. But let us calculate. 7c2 plus 3c2. 7 6 are 42 by 2 21. Wait a minute. This is 6 5 are 30. 30 by 2 is 15. This would be 15. 15 plus 6 would be 21. Okay, this would be 21. This would be 21 plus 3. 24. We are increasing from 20. We came 21. Here 24 ages would be there. This would be 8c2 plus 2c2. 28. 8c2 is how much? 28 plus 1 is 29. Here it would be 9c2 plus 1c2. 1c2 is 0 because from one vertex you cannot select two vertices. 9c2 is how much? 9 8s are 72. Divided by 2 is 36. So this is the maximum number of vertices which you can get, keeping the constraints in mind. So you make two different connected components. In one component there is only one vertex. In another connected component there are 9 vertices. And in those 9 vertices you make an edge between each and every pair of vertex. Okay. So this would be 36. Is it clear? Let's move to the next question. This is also an interesting question. What does it say? Consider the queues Q1 and Q2, Q1 containing 4 elements and Q2 containing none. So Q1 has 4 elements, Q2 have no elements. This is the initial state. The only operation allowed on these two queues are NQ and DQ. So NQ means you enter an element and DQ means you remove an element. The minimum number of NQ operations on Q1. What are the minimum number of NQ operations on Q1 required to take place? The elements of Q1 and Q2 in reverse order as shown in the final state without using any additional storage. So without using any additional storage, I want to place these elements 1, 2, 3, 4 as 4, 3, 2, 1 in Q2. Then what is the minimum number of NQ operations on Q1? So what I need to do is I need to minimize the number of NQ operations on Q1. So how can I do that? You see here if you do it, try to do it quickly, you might get wrong answer. For example, this is Q1. Now I want Q2 as 4, 3, 2, 1. So the first step is obviously to remove 1 from Q1 and enter in Q2. So my Q1 will become 1, my Q1, your Q2 is empty, okay? Q1 will become 2, 3, 4 and Q1 will become 1. Now remove 2 from here and enter it here. So this will become 3, 4 and this will become 1, 2, okay? Now here is what the mistake do people. They first NQ all the elements, then remove them, then enter 3 elements. So here it becomes 4, then 3, then 2, then 1 and so on. But that's not the correct way. We do not have to worry about the time complexity. What it is said that the number of NQ operations on Q1 must be minimum. So what I will do is I will remove this 2 from Q2 and I will remove this 1 from Q2. I will DQ it and NQ it in the same queue. So I will remove 1 from here and NQ it here only. So this will become 2, 1. Are you getting my point? This is 3, 4. Now I remove 3 from here and enter it here. So this became 4. This became 2, 1 and 3. Okay. Now I will remove 2 from here and NQ 2 in Q2 only. So this will become 1, 1, 3, 2. Now I will remove 1 from Q2 and enter it in Q2 only. So this will become 3, 2, 1. Am I getting what I required? Yes. Now 4. This is still 4 only. So I'll NQ 4 here. So this will become 3, 2, 1, 4. Now I'll DQ 3 and NQ here only in Q2. So it became 2, 1, 4, 3. Now I'll DQ 2 and NQ here only. So it will become 1, 4, 3, 2. Now I'll NQ1 and DQ1 and NQ here only. So this will become 4, 3, 2, 1. So this is what I required and Q1 is empty. So this is the final state. How many NQ operations I did on Q1? 0. So my answer is 0. Okay, is this clear? Let's move to the next question. Is this clear, guys? Okay, let's discuss the next question. What does this say? Let G be a connected, undirected, weighted graph. So it is undirected, so the edges do not have a direction. It is weighted, means the edges will have a weight associated with it, and it is connected, means there is a path between each and every pair of node. Consider the two statements. There exists a minimum weight edge in G which is present in every minimum spanning tree of G. So there is a minimum weight edge which is present in every minimum spanning tree of G. What is the minimum spanning tree? It means it is a tree which is a subgraph of the given graph which contains all the vertices of the given graph, and the sum of weights of edges is minimum. Okay, but does there exist a minimum weight edge which will exist in each and every minimum spanning tree? No. Why? Because let's say this is my graph 1, 2 and 3, and the edges have weight 2, 2 and 2. So 1 and 2 and 3. This is also a minimum spanning tree. This is also a minimum spanning tree, right? So this will also be a minimum spanning tree. So here the edge between 1 and 3 is not there, here the edge between 1 and 2 is not there, and here the edge between 2 and 3 is not there. So first statement is false. If every edge in G has distinct weight, then G has a unique minimum spanning tree. Obviously true. Why? Because if the edge weight is distinct, then what will happen is you will select the edges whose weights are minimum while selecting. So for example, if let's say the weights here are, here all three of them are minimum spanning tree, but if the weights are 1, 2 and 3, then I will remove this edge with weight 3 because I want minimum spanning tree, means the 1 plus 2 is 3, that is the minimum spanning tree. Minimum spanning tree means sum of edges of the tree is minimum, so that is minimum. So S1 is false and S2 is true. So your C option is correct. Is this clear? Okay, let's look at the last question for today. What is this question say? Let H be a binary mean heap consisting of n elements implemented as an array. What is the worst case time complexity of an optimal algorithm to find the maximum element in H? So H is a binary mean heap. Like, what is mean heap? Mean heap means a node will have smaller value than all its children, and this will be true for all the nodes. For example, we saw a max heap before some time, right? This was the max heap. 48 was greater than 45 and 45. 45 is greater than 41 and 43. 45 is greater than 40 and 42. 42 is greater than 20 and 32. 40 is greater than 38 and 36. This is a max heap. Now it is mean heap, means the root node will have the smallest value, then larger than that values will be below that, then larger than that values will be below that, and so on. Okay, so it is said that what is the time complexity to find the maximum element in a mean heap. So what is the time complexity to find the maximum element in mean heap? You see here, let us construct a mean heap and you will get a better idea. This is a mean heap. The root node has values less than all the children. 1 is less than 2 and 3, 3 is less than 6 and 7, 2 is less than 4 and 5, 4 is less than 8 and 9, 5 is less than 10 and 11, 6 is less than 12 and 13, 7 is less than 14 and 15. Okay. Now they are saying what is the time complexity to find the maximum element. To find the maximum element, what is the worst case time complexity? Now you see here the maximum element is at last index, so you can directly return the last index, but it is not necessarily the case. Okay, don't confuse between binary search trees, and even in that also, if it is implemented with the help of an array, it will not be on the last element only, right? So this is implemented with the help of an array. Okay, so this is 0 index, this is 1 index, this is 2 index, this is 3 index, this is 4th index, this is 5th index, this is 6th index, this is 7th index, this is 8th index, this is 9th index, 10th index, 11th index, 12th index, 13th index, 14th index. Okay, now you see here the maximum element is here, but it could have been here also. For example, if I say this is 16, now this is the maximum element and this is also by mean heap properties are satisfied. Or I may say this is 17, then this is the maximum element and still it is mean heap. Or I could have said this is 18, then this is the maximum element. Or I could have said this is 19, then this is the maximum element. Or I could have said this is 20, then this was the maximum element. Or I could have said this is 29, now this is the maximum element. Or I could have said this is 38, now this is the maximum element. What am I trying to say is, at the last level, maximum element can be present anywhere in a binary mean heap. Okay. So what you need to do is, in the array, you need to check the last n by 2 elements. Now, maximum element cannot be present in the second last level. Why? Because let's say this is the maximum element and there are 2 children of it. Now it is a mean heap. Mean heap means what? The values in the children will be greater than this node, but this is maximum element, its children cannot have value more than that. So this is not a maximum element. So what am I trying to say is, maximum element always lies in the leaf node. So you need to check last n by 2 elements in the array, which means you need to traverse half of the array, which means your time complexity would be big O of n. Don't tell big O of log n, okay? The answer will be big O of n or theta of n. Okay, is this clear? Okay, so that's all from this video, this session. I hope you people liked it.